Hello, Robotics 20 students. Welcome to our first week of online course for Robotics Intermediate. I'm just giving you a brief overview of the assignment that I'm going to have you working on for the next handful of weeks. I'm giving you plenty of time to work on this. I'll put out lots of content as well around all the details. Before I get into that, though, I just want to let you know about the kind of office hours that I'm going to be holding. So we're going to be doing online like office hours, drop-in times where you can hop into a Google Meet with me and ask any questions you might have. Share with me your files, and I can take a look and walk you through some tips, things like that. If you just want to come in and chat and hang out and chat with some other students, talk about what you've been up to, games you've been playing, any stories you want to share, whatever. But all of that can happen in our drop-in office hours, which I'm going to schedule every week, Tuesday, Wednesday, and Thursday from 2 until 3. So for that hour every week, Tuesday, Wednesday, and Thursday, I'll be in a Google Meet video conference, and you can hop in and ask any questions or chat or whatever. So I'll put specific instructions of how to access that in the D2L today, and maybe I'll see some of you later today or tomorrow or Thursday, and if not, then maybe next week. For today, though, I want to just go over what I'm going to have you do. So in our D2L shell right now, Robotics Intermediate, you should be able to see this assignment. It's called Sensors Research Experimentation Assignment. Basically, I'm just asking you to research a handful of different kinds of sensors and then make a circuit using them, write a little bit of Arduino code, and verify that it does the thing. So if you have Arduino kits yourself, you can make it in person and just like maybe take a video of it working or whatever. If you don't have an Arduino kit from last year, you can hop onto Tinkercad. I'll probably do some more instruction around the Tinkercad kind of circuit simulator, but it also can simulate Arduino code. So you should be able to do all of this from within circuits in Tinkercad as well. It's a little more fun if you have it physically in front of you. Another option is I can lend out, or actually I can just give you one of our spare Arduino kits in the lab. So let me know if you want to do that. I can make sure it's in the office, and then you can go and pick it up sometime. So please just let me know about that. So here's the assignment. In this assignment, you're learning about a variety of electronic sensors that could be used in robotic systems. So all I want is a single document. And then if you've done some building on a breadboard or in circuits and have taken some videos, you could just embed those videos into the document if you do like a Google Docs kind of thing. There are down below here a number of different sensors to look into. For each one, I need you to answer the following questions. Is it active or passive? What does that mean? Okay, I'll give you the rundown right now. Active versus passive sensors. Passive sensors are a sensor that is kind of it's like stupid. It's just like a thing whose properties change based on its environment, but there's no like electronics or like logic going on. So for example, you'll see below, you're going to look into thermistors, which is just a resistor that changes its resistance based on the temperature. And it doesn't need to be plugged into anything to be doing this. Like just a thermistor sitting in a box is changing its resistance based on the temperature it's experiencing. Now we can hook that up to an Arduino cleverly to sense those changes and then map those changes to some known degrees or Fahrenheit or whatever. But the thermistor itself isn't really like doing anything. We don't need to like power it or send any signals to it for it to work. On the other hand, something like the ultrasonic rangefinder, which sends out a pulse of ultrasonic, and then when it receives that pulse back, it tells us something about the amount of time that took. That would be an active sensor because it's doing something, or we're asking it to do something. So we're sending it some signals so that it can do its thing, but it's not just happening kind of passively. Okay. Most of the ones we'll look at, actually, I think it's kind of 50-50. If you have questions about that though, just ask, like don't guess. Like, you should all get 100% on this because you can just ask me and I'll tell you the answer. But we'll have a conversation about it. And that's what those office hours are for. I need you to describe what the sensor physically actually does in order to produce a signal. So we just talked about a thermistor. So the resistance changes based on the temperature. That's enough for you to describe it. Maybe you could say, so we measure the difference in the voltage drop across it and use that to make a guess of what the temperature is. What kind of signal is produced? Digital versus analog. So a recap, digital signals are signals that are either zeros or ones, high or low, on or off. So in the case of like a button, that's a digital signal, right? It's either pressed or it's not pressed. In the case of, some of them are a little tricky. Okay, in the case of like a speaker, that's going to give us an analog signal because it can be any range of values. Okay, it's a fluctuating voltage on a wire, and that's like a wave. So that's something that's analog. Something else analog would be like a potentiometer, right? You can turn it to any value between all the way off and all the way on. Some tricky ones though are like the ultrasonic range finder, which we'll look at in a later video, is actually producing a digital signal, even though it can take any values, in terms of it's really close or it's really far away or anywhere in between. So for some of those specifics, I'll make a video about each of these. Lastly, this is where I need you to just be a little bit creative. What's an example of a situation where a robot would need to use this kind of sensor? Okay, so if it's a sensor for sensing distance, your answer should not be a robot would use this when it needs to measure distance. Okay, like that's obvious. Okay, but why would a robot want to measure distance? Okay, maybe it's using it to avoid an obstacle or to approach a wall and slow down as it approaches. Okay, those are some examples. Next, I ask you to implement a simple Arduino program that reads the value of a sensor and prints the value to the serial monitor. And for basically all of these, I'll make tutorial videos using circuits in Tinkercad. So if you're unsure and you've forgotten everything you learned about Arduino, don't worry, we'll get into it. Okay, I'll make videos. You can also look online. There's tons of tutorials out there. Just, look around and make something that works. Make this code as simple as possible so you can use it as reference later on. Next year, if we're making some robots and you're like, oh, I want to use this rotary encoder. Oh, well, last year I made this quick program that gets the values from a rotary encoder. So I can just copy and paste that in and tweak some things to make it work for what I'm doing. So copy paste your code into your document. Make sure it's commented so that you remember what each part does and so that I know what you're talking about. And again, just make sure you remember there's so much information online about Arduino and examples and tutorials and blogs and videos and whatever. So just look into that yourself and remember that learning to read documentation and finding answers on the internet is an industry standard skill. This is the number one skill that I can teach you, is how to Google things. Okay, everyone in industry spends most of their time Googling things, searching things up. Okay, so I won't go through this list of sensors. You can look through it yourself. And if you have questions, send me an email, send me a message in our private discussions in D2L, whatever you need to do. Okay, so hopefully I see some of you guys in the classroom and we can have a little chat and catch up and see how you're doing. But if not, I will talk to you maybe next week or shoot me an email or whatever. Okay, have a good one. Bye, guys.